that's a lot. I scared my roommate's cat. Find the volume of the solid generated when the region between the graphs of the equations f of x equals 1/2 plus x squared and g of x equals x over the interval 0 to 2 is revolved about the x-axis. Wow, that's so much, so many words. So I fell asleep in the middle of it. I did not. So, find the volume of the solid. There's 2 equations. That's weird. What do we do with that? I don't know. Let's try something, you know? Let's graph them. First step, graph them. X squared plus 1/2, or 1/2 plus x squared. That just means, like, we have one, we go a little bit. This is just a parabola that is upwards. It's shifted upwards a half. So that's that. And then y equals x, that's easy. That's just the line, y equals x. So that's y equals x. This is y equals 1/2 plus x squared. I know that was called f of x and g of x, but I don't care right now, alright? You understand? I don't care right now. So settle down. And we're trying to find from 0 to 2. Was to 2. That's okay. It's 1, 2. Very good. That's this. Ooh, it's going to revolve this about the x-axis. That's interesting. So maybe I'll shade that. That's terrible. I'm going to shade it like I did before. So that's what I'm revolving about the x-axis. That's interesting. What kind of solid would that make? Kind of, if I swing this around, it'll make kind of like a cone, but on the outside, it'll be like that. Right? I think so. I'm going to try to draw it as best I can. And on the inside, so there's that circle there. On the inside, it looks like that. Except for it meets in the middle. Now, this is not too important that you understand this part, but I think it'll be. It's like a little lampshade. If you turn your head to the left, it's like a lampshade. So that's the volume that I'm going to try and find. Find the volume of the solid generated. So really, what are we doing? Let's think about this. First, if I were to have this volume filled in. Oh my goodness. I wasn't recording this whole time. Whoops. Okay, let me explain. I don't know what I recorded and what I didn't record. This would be the solid, kind of looks like a lampshade. I said that. Ooh, that's even better. I like that. And the inside is hollowed out. So this is all volume here. Volume. The inside is hollowed out. And so what we're really doing is we're taking the volume of the whole entire thing as a solid, and we're surgically removing, we're cutting out, we're getting rid of the, oh man, I said it's bone marrow, and then I made a bone marrow joke. We can just say it was hilarious, okay? I'm not going to repeat it though, because then it's not funny to me. So, what was I doing? What we are really doing is finding the volume of this entire revolution solid, and we're cutting out the inside. But the volume of the inside, oh, and this is the integral of that entire solid. I hope this is making sense. I wish I recorded it the first time. So, the whole entire solid is just the top function, right? Just the top function, just like normal, with that being the radius, and you rotate it around. Integrate it from 0 to 2. But we're not looking at that right now. We want to know the inside, because we want to remove the inside. That would be that solid, right? We want to remove. I like to remove it. We got to remove that inside cone. So let's figure out the integral for that. That's just the bottom function. Undo. The bottom function. So I'm going to start with pi. Integral from 0 to 2, of course. And the radius squared, the radius here would be y equals x, so it's just x. So it'll be x squared dx. And that represents the area of the cone. The area of the cone. So it's different. So we're taking out the inside. So really, what do we got to do? We just got to subtract these integrals. Yeah. So what we will have is pi, this is undo. The integral well, I'm subtracting these two. I can do from 0 to 2. They have the same limits. You see? You see? They have the same limits. So subtracting these integrals would be the same thing as going 1/2 plus x squared, quantity squared, minus x squared, and then dx. It's kind of like I factored out that pi. Yeah. So that's really what I'm going to be integrating, and that will give me the area of this little lampshade thing sideways. Turn it sideways. So that's what I'm going to be doing. I hope that made sense. I know it probably didn't, but you know what? I don't care. Just try and make it make sense. Let's do this integral. So 1/2 plus x squared quantity squared. That's just 1/4 plus x squared plus x to the 4th. I'm going to double check that. Yup, that's what it is. That's what it is right there. That's what it is. So I'll keep going.